I'm going to be going over the routines for a forearm projection. It's pretty simple for the forearm. You just have your AP and your lateral. That's all you have for the forearm. And what you're looking for in both of these, for your AP and your lateral, you're going to be looking for fractures and dislocations of the radius or ulna and pathological processes such as osteomyelitis and arthritis. You're going to be doing 40 SID for both projections. For smaller patients, you can use an 11 by 14 hour, or you can use a 14 by 17 for larger patients. I don't have a 14 by 17, so we're just going to have to pretend. But you want to make sure that you're in the center of the eye, or whatever size you're using. And your KV range for these is going to be 70 plus or minus 5. You want to make sure you shield any radiosensitive tissues outside the region of interest. You seat the patient at the end of the table with hand and arm fully extended and palm up or supinated. So that's how you start your AP, is just like this. With the arms out like this. You want to make sure you drop the shoulder to place the entire upper limb on the same horizontal plane. Align and center the forearm to the long axis of the IR, ensuring that both wrist and elbow joints are included. Use as large as an IR as necessary to make sure you are joint to joint for a forearm. You want to be from this joint to this joint. And you want to instruct the patient to kind of lean. They're going to have to lean a little bit to place the entire wrist and forearm and elbow as true frontal position as possible. So you don't want to over lean and get like this, but you want them to lean just enough to where it's in true form. Because see, if I'm like this, and this is me just sitting regularly, not rotated or anything, it's not true. You just want to lean just a little bit to make sure you get those epicondyles in a true frontal position. And you want to palpate the medial and lateral epicondyles to ensure that they're the same distance from the IR. And your central ray is going to be perpendicular to your IR, directed to the mid forearm. And you want to make sure you collimate the lateral borders to actually the forearm area with minimal collimation at both ends to avoid cutting off any anatomy. And consider divergence of the X-ray beam. Ensure that a minimum of 3 to 4 centimeters or 1 to 1.5 inches distal to the wrist and elbow joints are included in the IR. So like we said, for the AP, you're wanting your centering at the mid forearm. So I would say like right in here, because you're joint to joint, remember. So I'm going to center like right in here, and I'm going to make sure you want to do that roll just a little. You don't want to over roll, but you don't want to just be like this either. You want them to be rolled just a little bit so you get that position. And make sure them epicondyles are parallel to each other, and you want to center about right here. And then for your anatomy demonstrate on that, for the AP projection, you want the entire radius and ulna with minimum and proximal row carpals and distal humerus, and you want your soft tissue such as fat pads and straps of the wrist and elbow joints. For the positioning, you want no rotation, and the humeral epicondyles visualized in profile with radial head, neck, and tuberosity slightly superimposed by the ulna. And your wrist and elbow joint spaces are only partially open because of the beam divergence, and the central ray and center of collimation field should be to the approximate midpoint of the radius and ulna. And exposure, you want optimal density, and contrast with no motion should be visualized the soft tissue and sharp cortical margins and clear bony trabecular margins. So that was your AP. Now we're going to go into a lateral. It's going to be kind of hard to demonstrate on my table. I might have to scoop myself down some. Your lateral is going to be like this, not this. Your lateral is this. So you're still looking for fractures and dislocations of the radius or ulna, pathological processes such as osteomyelitis or arthritis. You're still using 40 SID, you want to do the 11 by 14 or 14 by 17 for long forearms, and you want it to be in portrait. And still 70 plus or minus 5. And to make best use of the anode heel effect, place the elbow at the cathode end ray of the beam, of X-ray beam. You still want to shield your radiosensitive tissue. Seat the patient at the end of the table with elbow flex 90 degrees. That's the important thing for a lateral, is you're flexing that elbow 90 degrees. And so you want them, when they're like this, you want to either kind of drop their shoulder or you have to build them up. So I'm going to say, try with a couple textbooks here as my IRs. You might have to build them up with whatever you're using to get that true lateral, because it's going to need to be horizontal with that shoulder. You're going to have to build it up. This still isn't built up all the way, but this is to just show an example that you have to build up sometimes to get your laterals. And you still might be able to drop the shoulder even when you're built up. That way it gets that true lateral position. I might have to move back some so you can see the elbow. That might be better. Here, I move myself in. There we go. You want to drop the shoulder and place the entire upper limb on the same horizontal plane, which means, like I was saying, you have to be built up. So make sure you're in true lateral position. You want to rotate the hand and wrist into a true lateral position. So you don't want it like this. You want it up like this still when you're up. So to bring that up like that. And then another thing I forgot, your portrait. So should be like this. And of course this isn't long enough to get the whole forearm, but your IR would probably have to do 14 by 17. But you're in portrait. You got that true lateral because you're built up and your shoulders drop to get that horizontal plane, and you want your hands still like this. You want it up like that. You want to ensure that the distal radius and ulna are superimposed directly. For heavy muscular forearms, place support under hand and wrist is needed to place radius and ulna parallel to the IR, and you want it still centered. Your central rays perpendicular and centered at the mid of the forearm. And you still want to collimate, still leaving some room for, fat pads and whatnot. You want to make sure you're still going joint to joint. And this obviously isn't long, but that's your lateral position pretty much. True lateral position. The anatomy demonstrator, you're going to do, it's going to have a lateral projection of the entire radius and ulnar proximal row of carpal bones. Elbow and distal end of the humerus is visible, as well as your soft tissues, such as your fat pads, straps of the wrist and elbow and joints. So you want to make sure your soft tissues margins are in there. You want the long axis of the forearm aligned along the axis of the IR. Elbows should be flexed 90 degrees, no rotation. As evident by the head of the ulna being superimposed over the radius and humeral epicondyle should be superimposed. Radial head should superimpose the coracoid process with radial tuberosity demonstrated. The central ray of the center of collimation field should be at the midpoint of the radius and ulna, and you want optimal density and brightness and contrast, no motion visual, and you want your sharp cortical margins and clear sharp bony trabecular markings and fat pads, straps, the wrist, and elbow joints. So that's your routine forearm projections. I'm going to leave this built up, but we went from AP, a little bit of the roll on there, centered at the forearm, joint to joint, epicondyles, make sure they're parallel. Then we went from that to the lateral 90 degrees. Like that. And that's it.